And welcome back to the morning show coming up on 6:50. It is Wednesday. That means it's Wise Guy time. Our very own U of I physics professor, Matt Sellon, is back. Matt, thanks for coming back after a 2-week break.
Oh, yes. Well, you know, I had to forward my acting career as the bookseller in Beauty and the Beast.
I heard that. How'd it go, by the way?
Oh, it was great. I mean, no thanks to me or anything, but the people did a great job. It was really cool. So anyways...
we'll move on to hot
Speaking of really cool...
Yes, you're a great transition.
So this was actually suggested by one of the viewers, Corinne, who sent me an email asking about these reheater packs, which I'm going to talk about in the second segment. They're just about the coolest things ever, if you'll forgive the pun, because they're hot. But anyways,
I got it.
So I decided, well, okay, I'll see what other kind of things you find there in the drugstore, because, you know, we all know about cold compresses, like you put something in the ice box and take it out and you put it on, but that's kind of boring, you know. Or you take the thing that you boil in the water and you have like a hot water bottle. That's a little boring.
I use a bag of peas every once in a while.
I believe in better living through chemistry. So you can do the same thing with just chemicals. Okay. And so you have something which you can keep in your first aid kit, like, for example, these cold compresses like this. And if you play sports or something, you might have seen somebody hurt their ankle, and they'll whip out one of these things and they'll do something to it, and it gets really cold, and they'll slap them on your ankle.
Right.
And so I'm going to explain how these things work, as well as some hot pads and stuff like that. It's really cool. And so so we'll start with just basically chemical reactions. When chemical reactions are when you know, compounds break apart and rearrange themselves, and this always involves, or just about always involves, a change in energy. Energy is given away, or energy is taken in when that happens. And we're very familiar with this, and the things we know about most are ones that give away energy, exothermic reactions like burning.
Right.
Okay, burning gives off energy. When we digest food, that obviously gives off energy because we get energy to run around. But there are some reactions that actually suck in energy and make things colder. And a very common one, which oh yes, where's my little bottle here? Sorry.
Oh, you're good.
Here we go. Is something you can do at home, which is just the baking soda reaction. Okay, so if I take a little vinegar, which I have in here, I'm going to dump it in here, and we can measure the temperature of this stuff, just so you know I'm not cheating. It's like 22 degrees or something like that.
22 and a half.
Yeah, and then if you want to hang on to that,
I got it.
I dump some baking soda in here, and it makes a huge mess on your table, but that's part of the fun.
That's okay.
And then it gets colder now. You'll see that this should go down. It's probably down to about 15 degrees, and you know, so this is an endothermic reaction. It actually absorbs energy, and if you stick your finger in there, it feels colder.
Okay.
Now, this is kind of a bad thing. If you want to have a cold compress, this stuff gives off gas, and you know, it would be not real handy, and it happens really quickly. You want something that lasts a little longer and maybe even gets colder. So you just have to look for some different chemicals. So instead of mixing baking soda with vinegar, you can mix ammonium nitrate, which is this stuff, with just plain water. Okay? And so I have some just plain water here that I got, and I mix this with the ammonium nitrate, which was in here. And you just sort of mix the stuff up, and it gets really, really cold. So if you stick the thermometer in there now, I'll hold that.
Okay, I'll hold this.
And you can hold your hand underneath this thing, and you can sort of feel that it gets cold. And this stuff will get down very quickly to... So it's already down to 7 degrees Celsius. 0, remember, is freezing. So this stuff can actually get you frozen real quick.
Very good.
Okay? And this stuff will last for a little while. It stays cold because this reaction isn't as quick as the one we just saw. So when you're designing these things, the key is you want ingredients that are kind of easy to get, that doesn't happen too fast, that doesn't involve releasing dangerous chemicals or anything like that, and it's fast. And so when you get these things at the drugstore, there's a pouch of water, there's a pouch of this ammonium nitrate, and when you kind of just squeeze it,
let it go,
they mix together, and it gets real cold, and then you can put that on your head, you know, after you get the baseball on the forehead or whatever it is.
All right, well, we're running out of time, Matt. Okay. We got a hot one coming up, and it's going to be real cool, so y'all watch that.
Yeah.